to study the biosphere atmosphere interaction. So atmosphere means climate, weather, biosphere, that life. Yeah, we have to understand the concepts of biomass. What is biomass? Not only plants, not only animals, also with specific climate, temperature, and precipitation. Yeah, plants, animal, and climate together. How to define this biomass? Yeah. So the biomass in the world, in the land, you can divide it into 8 or 10 different categories. Yeah, tropic rainforest, tropic savanna, yeah, and so on. So first, there are a lot of definition. However, let's take a look each of them, then see which would be better. A large geographic region having a defining climate to which plants show a similar physiological adaptation. So from here is the biome is about the plant's climate. However, has no word about animals, right? Yeah. Second definition is seeing the largest geographic biotic unit, a major community of plants and animals, which similar life forms and the environmental condition. Yeah, that is better, right? There's animals, plants, and weather. They did not see the weather. They see environmental condition. Third, Bauman shown regions in the world that share similar plant structures, plant space, animals, climate, and weather. Which you prefer? I prefer definition 3. Overall, this biome is determined by climate, long-term climate factors. What are the climate factors? Temperature and precipitation. Yeah. So all the land type is in this space, in this two-dimensional space. You see tropical rainforest, hot, right? And high precipitation. Yeah. Then you see savanna, the similar temperature, but much less precipitation. Right? Yeah. So this chart show us specific climate condition to produce specific biome. Here, from my paper, Joe is my first graduate student, and this table we did 10 years average for the vegetation. Yeah, if they have similar vegetation, we aggregate these climate factors: precipitation, temperature, PER, That's photosynthetic actively radiation. That radiation is used for photosynthesis. Yeah, fourth column is net radiation. Then dryness. Yeah, then you see what's the difference. For the broadleaf evergreen forest, there's a tropical rainforest. Yeah, high temperature, high precipitation. For for grassland and wooded sea grassland, you see temperature similar, PR similar, net radiation similar. Only different is precipitation. Yeah. So you can take a look about this. So here is a paper published by the scientist Hirsch. So this is called Hirsch life zone because life, plants and animals, is determined by three factors. Yeah, potential evapotranspiration. That potential evapotranspiration is about net radiation. Another is water, annual precipitation. Another is the humidity. Yeah, three factors. You can do them in triangle. Then, one part determined by these three factors. From here, you can learn if you know something is determined by three factors. You can use triangle. Each side represents one factors. Yeah, so then you can use this chart to express what you want to indicate. That is very, very important uh, climate factor, the climate index. Yeah. RA is the annual sum of net radiation. Net radiation. What is net radiation? Net radiation is the difference between incoming shortwave radiation from the sun. Yeah. Another is long wave radiation from the earth. This long wave radiation is going out to the space. So the difference, it is available energy at the surface. Yeah. So if this net radiation lambda is a constant of latent heat. Yeah, that means is converted 1 kilogram water. How much energy used? 2.5 magma joule. Yeah, so that's latent heat. Yeah, yeah. P is annual sum of precipitation, the total precipitation in a year. So this net radiation over lambda is called annual sum potential evapotranspiration. What does this mean? This means the total energy available on the surface, net radiation. If that is all used to evaporate water, how much water will be from liquid become gas? Yeah, so that's the total. That's maximum evapotranspiration. All the energy is used for the water to become gas. Then you can see how much water can be converted into water vapor. Yeah, that's a potential evapotranspiration. So that's interesting. Potential transpiration over P. Yeah, that is called dryness. Yeah. If D is less than 1, what does this mean? This means so if the total available energy all is used to evaporation cannot evaporate the total precipitation. There is some left over of the water in the soil, so the soil is wet. Yeah, so the D is less than 1 means wet. So easy to understand. If D is greater than 1, that means dry. Yeah. So we call it dryness. This is a beautiful index and formula. Very, very simple. Simple is beautiful. Yeah. This simple index, however, it is a combination of energy balance and water balance. They can combine two important balance, energy balance and water balance. Index was created, developed by Russia scientist Budiko. Yeah. So this Budiko used this index and net radiation to clarify biome. Yeah. You can see different dryness and different net radiation. Uh, so that's a support different vegetation. Yeah. That's a forest. Yeah. Steppe, semi-desert, and the desert. Yeah. This net radiation, you see the difference. That's because that's from different latitude. Yeah. In the tropic, net radiation is larger. So tropic rainforest, wet savanna, then subtropic. Yeah. Okay. The Buddhic use his dryness index to classify vegetation for the globally. Yeah, that's interesting. There are some papers there. Yeah. Oh, this biome, you can know Tibet. This Taurus mountain is there from the sunset of the Tibet, from bottom to the top. Yeah, from cold to from the warmest to the coldest, from more precipitation to the dry. Yeah, the vegetation on the sunset of Tibet mountain, you can see tropical rainforest, decidual forest, conifer forest, tundra, yeah, latitude, vegetation belt from bottom to the top. You can clearly demonstrate this spectrum of vegetation. This vegetation, if you from tropical to the North Pole, is similar. The similar spectrum, the same order. Tropical rainforest, decidual forest, conifer forest, tundra, yeah, similar in the horizontal. Tibet sunset of the Tibet mountain in the vertical. Yeah, yeah. So these similar vegetation distribution, similar biome distribution from bottom to the top of Tibet mountain and in a horizontal from tropic to the North Pole. From here, you know general circulation. General circulation is also for the climate, uh, determine the vegetation distribution. Yeah, tropical rainforest because that's active. Uh, because that's convergence of international zone. The moist, the hot air is going up. That's condensation. There's a huge rain. So the tropical rainforest. Desert are allowed, are located around this 30 degree in the north or in the south. Air is sinking. Air sinking is drying. So a lot of desert located in that latitude, right? Yeah. Okay. Here show you some climate change. Climate determine the biome. Yeah. Long-term climate determine the biome. Climate is the temperature and the precipitation. You see, air is motion, and the general circulation is the fast process and the motion. Yeah. Most of the energy is transferred by the water. 70% of land surface is the water, right? Yeah. Water has maximum heat capacity. Yeah, specific heat. That means can hold more water, more energy per kilogram of water. Yeah. You can see in the low latitude, yeah, between land and the water, which one is the hottest? Hotter. Yeah, land. Water is cool. According to second law of thermodynamics, what is the transfer direction of heat from hot to the cold, from land to the water, right? You see, just like a train, they loaded heat energy from land to the water. Then the water carries this energy is going to the high latitude, right? At the high latitude, which part is hot, which part is cold between land and the ocean? Of course, land is cold, water is warm. According to the second law of thermodynamics, the heat is transferred from hot to the cold, from water to the land. You see, at high latitude, energy is loaded up from water to the land. Yeah, you see how this Earth system energy is transferred from a low latitude to high latitude.